Good afternoon. We know several things regarding quadratic function. Some of the important fact regarding quadratic function is the graph of quadratic function is a parabola. We already know how to find the vertex of a parabola. Today we are going to use our knowledge regarding parabola in some applied problem. One of the applied problem in case of any function, regardless if it is quadratic or not, is to find the maximum or the minimum or maximum and the minimum values of the function. In case of quadratic function, the good thing is, in case of quadratic function, a quadratic function can either have a maximum value or a minimum value. It cannot have both. So, associated with each quadratic function, there is a maximum value or there is a minimum value. We will use our knowledge of finding vertex of a parabola in finding the maximum or minimum value of a quadratic function, and we will see some applied problems that has to do with the vertex and some other properties of a quadratic function. So, the first thing, as I discussed, we will be interested in knowing what is the maximum value or what is the minimum value of a quadratic function. Well, the x coordinate of the vertex is where the maximum or minimum of a quadratic function occurs. If we can find the x coordinate of the vertex, we know where the function has the maximum or minimum value, and the y coordinate of the vertex is the actual maximum value or minimum value of the quadratic function. Another thing we need to note is, if a, the leading coefficient, is positive, if a is positive, we will get the minimum, the parabola will have minimum, and if a is negative, the parabola will have maximum. So, the value is the vertex is the maximum or minimum depends on the sign of a. A is positive means it is the minimum, a is negative means it is the maximum. The reason being this is, if a is positive, the parabola will look like this. So, it goes down, this is the minimum point. If a is negative, the parabola is downward, and this is the vertex and this is the maximum value of the parabola. So, let us look at one problem and we will apply this concept in this problem. Suppose there is a quadratic function f of x equal to negative 3x square plus 6x minus 13. The first question is determine where the function has a maximum, or determine whether the function has a maximum or the minimum value. So, in order to determine either this function has a maximum value or minimum value, we need to note the coefficient of x square, the number that multiplies x square. This is equal to negative 3, this is negative. Because this number is negative, because the number that multiplies x square is negative, or sometimes we call this a leading coefficient. Since the leading coefficient is negative, this function f of x has a maximum value. If this number was positive, then the function will have a minimum value. So, this function has a maximum value. Now, we already know the maximum value, and we want to, in number b, we want to find the minimum or the maximum value and determine where it occurs. So, we need to know what is the minimum value. We already know the function has a minimum value, and now we want to know how much is the minimum value, and we want to know where it occurs. the answer of this where is x coordinate. If we find the x coordinate of the point where the parabola is minimum, where the quadratic function is minimum, we found the answer for where. And y coordinate is in fact the actual maximum or the minimum value. And we already know that the maximum or minimum value of the parabola is given by the vertex. So, I will need to identify what is the vertex of this parabola. In order to identify the vertex of a parabola, recall we need A is -3, B is 6 and C is -13. Now, in order to identify the vertex, x coordinate of vertex is given by -b by 2a. If we want to find x coordinate of the vertex, it is -b by 2a. So, for this question b is 6. So, -6 by 2 times a, 2 times a is -3. So, 2 times -3, denominator is also -6, -6 divided by -6 is 1. So, x coordinate of the vertex of this parabola is found to be equal to 1. Now, y coordinate, so y coordinate of the vertex, we are working to find the vertex. Okay. Y coordinate of the vertex is given by f of, sometimes the x coordinate is written as h and y coordinate is written as k, and f of h gives the y coordinate. Do not confuse with what do we mean by f of h. We already know h is 1, we already know the x coordinate is 1. Now, in order to find y coordinate, we will replace x of this equation by this 1. So, we will replace x of the in the formula of the function by 1. So, -3 1 square 6 times 1 minus 13. So, this is -3 x 1 square plus 6 times 1 minus 13. So, we will get -3 plus 6 minus 13, 13 and 3 -16 plus 10 -10. That means then we can say that we already know it is a maximum value. Maximum value is -10 and it occurs at x equal to 1. So, basically what does this mean in graph is, if this is x equal to 1, the parabola looks something like this, and this is x equal to 1 and this is x equal to 1, and this is the maximum value, and this maximum value is this is a wrong graph, maximum value is -10. So, the graph should look something like this, x equal to 1. So, this is x equal to 1 and this is the maximum value and this is -10 and this is x equal to 1. Okay. So, we know how to find maximum value of the parabola, and the third question is also kind of interesting. Third question is, we need to find, so this is -10, we need to find what is the domain and what is the range of the parabola. Domain of this parabola or domain of this quadratic function is all the x values for this graph. So, if we look at the graph, you know, for this point x equal to -2, x equal to 0, 1, 2, 3, 4, 10 and so on. So, basically it comes from the infinity, goes to the infinity. So, any x value from infinity to -infinity is okay for this parabola. So, when we want to find the domain is from -infinity to positive infinity. So, I can say domain is everything. Domain is equal to negative infinity to positive infinity. The next thing is to find the range. Recall that range means the y value. If we look at the parabola, the y value is the maximum y value is negative 10, then it is always below negative 10, below negative 10 all the way. See this point y value is below negative 10, I do not know, maybe negative 20, negative 100, but we have, since this goes down forever, we will have every y value below negative 10. However, there is nothing above negative 10. For example, when x equal to 0, when y equal to 0, we do not have a graph. So, y value cannot be 0, y value cannot be 1, y value in fact cannot be even negative 5. If there is any number bigger than negative 10, that cannot be the y value for this parabola. So, the range basically is starting from negative 10 all the way up to negative infinity, because it goes down. So, starting from negative 10 all the way up to negative infinity is the range of this parabola. Well, so now we know how to find maximum or minimum of a parabola. So, we notice it is just nothing more than the vertex of the parabola. Now, let us look at an applied problem here. So, this problem says when a football is kicked, well, you can think this is American football, this is an NFL related game, or you can think this is soccer, which is basically football outside of United States. So, regardless of what kind of football it is, the problem will be the same. There is no change in the football. The problem depending on if it is American football or the soccer. So, basically a soccer or the football is kicked. The height of the ball f of x is modeled by, so the height of the ball is modeled by this formula. So, basically the football, the ball is kicked from here, it goes up and up, up and up. I do not know how it goes, we will figure it out. So, the height is this, this is x, the horizontal distance of the ball is x, and the vertical distance of the ball is height, which is given by f of x. So, f of x, the height of the ball is given by a function of x, where x is the horizontal distance of the ball, by this formula negative 0.01 x square plus 1.18 x plus 2, where x is in feet. So, we are measuring, we are using feet as a scale of measurement, is the horizontal distance from the initial point of position of the ball. So, something like that. Now, the first question we want to answer is what is the maximum height of the ball and how far from the point of contact it occurs. So, if we think of the question, see, let us say this is the starting position of the ball, it will go up, the ball will go up after reaching a certain height, it cannot go further up. Our question is what is this height, this is the maximum height, and how far from the initial position, what is this distance, So, this is what one thing we want to find, this is another thing we want to find. Well, for us, basically we want to find, this is a quadratic function, and this point for this quadratic function we call it a vertex. So, basically we need to find the vertex, and we already know how to find the vertex of a quadratic function. Well, as soon as you have a quadratic function, always note a, b and c, because we are going to have to use this to find anything we want. So, a is negative 0.1, b is 1.18 and c is a plus 2. So, knowing this information, now we will find where is the maximum height occurs. So, we will find the x of the maximum height first. Recall that x for we are finding for vertex we are looking for the vertex x coordinate is given by negative b by 2a, always the same formula. So, negative b for this question is what? Negative of negative 0. Negative b, how much is b? I will have to go back. B is 1.18. So, negative of, so basically negative of 1.18 divided by 2 times a is negative 0.01. A is negative 0.01. So, that means negative 1.18 divided by negative 0.02, negative and negative cancels out, 1.18 divided by 0.02 is positive, this is positive 59. So, the maximum height, the ball gets the maximum height 59 feet away horizontally. Horizontal distance of the ball from the point of start is 59 when the ball is at the maximum. So, basically in this picture this is 59. Now, in order to find the vertical height, in order to find the maximum height, remember we need to find the y coordinate. So, y coordinate of the vertex is f of h, meaning that in the formula of the function we need to replace x by 59. So, let us see the formula and let us replace x by 59. So, the formula is negative. So, negative 0.01, x is 59 times 59 square plus 1.18 times 59 and plus a 2. This is the maximum height of the ball. So, if we do this calculation, we will get 36.81. So, this is 36.81. Therefore, we could say maximum height equals 36.81 and occurs 59 feet from the initial position. Okay. So far so good. We found the maximum height of the ball. Now, the next question is how far must the nearest defensive player who is 6 feet far from the kicker's point of impact reach to block the ball. So, this is basically is the question. This is the point of contact of the kicker and the defensive player is sitting here and this distance is given to be equal to 6 feet. So, the defensive player is 6 feet away from the point of contact and we already know the ball will be going this way. We want to know how far this person here needs to jump to block the ball. How far this person needs to reach after jumping to reach the ball if the person wants to block the kick. So, basically if you look at the picture things is clear. So, for this point x value is already 6 feet and this is the path of the ball. We want to know what is the y value of the function when the x value is 6, because the person is sitting 6 feet away. We need to find the corresponding y value, that much the person should reach if the defender want to block. So, basically that what we are looking for in this question is f of 6. X is 6 f of 6 is the y value, f of 6 is the height of the ball, 6 feet from the point of start. So, this is according to our formula 0.01 6 square plus 1.18 times 6 plus a 2. If we do this calculation, we will get 8.72 feet. So, not a difficult job. If the person is 6 feet tall, the person had to jump 1.72 feet in order to reach the ball. So, basically the person has to reach 8.72 feet from the ground. If the person is already 8.72 feet, the person don't need to, including his length of the hand, he don't need to jump, he can easily block the ball. But for me, I am 5'6", so I have to jump a lot if I want to block the ball. Okay, so the second question is done. Okay, third question is, if the ball is not blocked, how far down the field will it go before it hitting the ground? So, the question is, the ball is kicked from this point, it again hits ground after some time. So, we need to know from this point how far it will go before it hitting the ground. So, we need to know what is this distance. This is what we want to know. Well, see, the formula of this path is given to be equal to negative 0.01 x square plus 1.18 x plus 2. If we think of this point and this point, well, this could be the situation, okay. This could be the situation. So, this is, we have to do more. See, the ball, this is the kicker's leg. So, the ball initially was here and it is going on the, it took this path and it comes down up to here. So, we want to know, this is the initial position of the ball, we want to know how far horizontally the ball traveled. For us, this is a simple question. For this point, the function, the height is 0. This is the formula for height, and for this function, because it is touching the ground, the height of the ball at that particular point, at this particular point is 0. So, basically if we replace this by 0, we will get negative 0.01 square plus 1.18 x plus 2. Now, we need to find x from this equation. This is a simple quadratic equation. Basically, the question is solve this quadratic equation. So, if I want to solve a quadratic equation, remember that if we want to use quadratic formula, we need to know a. So, this is my a for this quadratic equation, this is my b for this quadratic equation, and this is my c for this quadratic equation. If I use the quadratic formula, very famous quadratic formula, we will get x equal to, recall the formula, negative b plus minus square root of b square minus 4ac divided by 2a. So, this will be negative of 1.18 plus minus square root, b square is 1.18 square minus 4, a is negative 0.01, c is 2 divided by 2 times a, 2 times negative 0.01. Using calculator, this will turns out to be, well, one is taking plus, another is taking minus, it should give two answer. one answer in fact corresponds to this point. This is our starting point, this is our 0 comma 0. This point will indicate one of the x value, and this another x value will represent this point. So, if we solve this, one x will come to be equal to negative 1.07, that corresponds to this, and another x turns out to be 119.7, 119.7. So, this is the quantity we are looking for. This length is 119.7. Okay. So, well, the next one, it says graph the path of the ball. We already have the graph for the path of the ball. If you want to graph it properly, use a graphing paper, and you know one of the point you want to graph is this is 0. When x is 0, you can find, if x is 0, you can find y is 2. One point is this. Another point we already know, in fact, is this. This is x is 119.7 and y is 0, and there was another point also, if you remember, the maximum point of the parabola. So, 6 and 8.72. So, the third point is 6 and 8.72, 6, 8.72. So, you know, if you have a good graphing paper, 0 is 2, 0 is 2, this is one point, 199 and 7, this is another point, 6 and 8.72, this is another point. This is a parabola, so you know you can have a graph something looking like this. Okay. So, this is an example where regarding kicking a ball applied in case of a soccer or football. Now, let us look at one more applied problem. It says you have 100 meter of fencing material, you want to enclose a rectangular region, find the dimension of the rectangle that maximizes the enclosed area. What is the maximum area? So, this is what the basically question is saying. You have 100 Okay, you have 100 meters of fencing material, you want to enclose a rectangular garden. So, this is the rectangular garden we want to enclose. So, the total length of the fence is 100 meter. So, one way you can enclose the rectangular garden is take, this is for example 45, take this 45, 45 and 5 90. So, take this 5 and take this 5. One way the fencing material can be used is this. Well, another way I probably can use is this way. Let us say I will take this to be 10, this to be 10. So, 20 is gone, 80 is left. So, 40 here and 40 here. If I do this way, if I take 45, 45, 5, 5, then the area is 45 times 5. So, 45 times 5, which is 225. So, the area I will enclose will be 225 if I do this way. Instead, if I do this way, the area I enclosed will be 40 times 10, 400. You can see I can enclose more area if I do this way in compared to this way. So, the basically how we structure the rectangular plot determines how big the area we are enclosing. So, now here in this particular question we want to find how much should be the length of the rectangle, how much should be the width of the rectangle, so that the area is the maximum. So, let us formulate the problem. So, I will say let x be the length of the rectangle with maximum area. So, what I am assuming is here is a rectangle of maximum area and I am thinking the length be x. I do not know how much is x, we have to find that x, but I am assuming that value be x for right now. If this is x, of course this should be x. Since the perimeter is 100, since the fencing is 100, this should be 100 minus 2x divided by 2, or I could have said 50 minus x, and this should be also 50 minus x. So, therefore, we could say therefore, width of the rectangle, this is nothing more than 50 minus x, because by adding all the 4 sides we have to have 100 meters, because that is the total fencing material we have. So, now there is a rectangle whose length is x, width is 50 minus x. We know the area A for the rectangle is given by x times 50 minus x, x times 50 minus x. Okay. Well, if we multiply these two, we will get 50 times x, which is 50x, minus x times x is x squared. So, basically if we look at this formula, area is a function of x and it is a quadratic function, and we are thinking this area be maximum. That means we are thinking, we are trying to know what should be x for this quadratic function to be maximum, and we already know in order to find maximum value of any quadratic function including this quadratic function, we need to find the vertex of the quadratic function, and we already know the formula for the vertex also. So, in order to find the for maximum value, the x coordinate must be negative b by 2a, negative b by 2a. So, for this quadratic function, a is negative 1, b is 50 and there is no c, so c is 0. So, if I use this formula, negative 50 divided by 2 times a is negative 1, so 25. So, x should be 25, that means the length is 25, width is 50 minus x, 50 minus 25, 50 minus x, 50 minus 25, which is also 25, and if we want to find the area, length is 25, width is 25, so the area of the rectangular plot will be 25 times 25, I think it is 625. So, the maximum area we can enclose with the help of that 100 meters of fence is 625 square meter, and that particular rectangle should have a length of 25 and the width also of 25.